Now we're doing the review for section 7.1, and we're given that the hypotenuse of a right triangle is 5 inches. If one of the legs is 2 inches, find the degree measure of each angle. Okay, then by the Pythagorean theorem we know, we'll just call this x. X squared plus 2 squared, which is 4, equals 5 squared, which is 25. So x squared equals 25 minus 4. So x squared equals 21. So then x, it's got to be positive, equals the square root of 21. So square root of 21. Now let's call this angle A. And so we know for angle A, the sine of A equals 2 over 5. And so now to isolate A, we'll take the inverse sine of both sides, and the inverse sine of 2/5, which is 0.4, and that's an angle, by the way. That equals 0.4, and it's an irrational number, and it's going to round to 0.41. And now let's convert that to degrees, so we have 180 degrees over pi, multiplying by the unit multiplier, and I get approximately 24 degrees. So if we call this angle B here, then B will be, so the measure of A equals 24 degrees. B is going to equal approximately 90 minus 24, which is 66 degrees. Yep, 610, 3 and yep. And we know the third angle, and I'll call it C. C equals 90 degrees. Okay. And we're done. Let's see, did we do it? Yeah. Yeah. And the reason we said approximately, because the angle was in radians was an irrational number, so the best we can do is get an approximation. Well, now we're doing question 2 on review 7.1, and it says a DC-9 aircraft leaves Midway Airport from runway 4 right, whose bearing is north 40 degrees east. After flying for 1/2 mile, the pilot requests permission to turn 90 degrees, head towards the southeast. The permission is granted. After the airplane goes 1 mile in this direction, what bearing should the control tower use to locate the aircraft? Well, let's do a little rough drawing of what's going on here. And so this is east, west, north, and south. And the airplane went north 40 degrees east, north and 40 degrees east, and puts it about like that. And it went for 1/2 mile. And by the way, this is the 40 degrees. And this distance is 1/2. Then it took a right turn to the southeast, or made a right angle, I beg your pardon, in a direction towards the southeast, and it traveled for 1 mile. And this is a mile, 1/2 a mile. Now, let's find the length of this. Or, excuse me, we don't have to find the length of that, but this is the direction it's going in. If we were going to excuse me, this is the direction it's going in, but if we were going to plot its location, we'd have to do it in terms of south and so many degrees east. So let's see. Let's call this angle right here theta. And we know, yes, well, let's do this. So the tangent of theta equals rise over run, 1.5, and when we invert and multiply, tangent of theta equals 2, so theta equals the inverse tan of 2, which equals approximately 63.4 degrees. Okay, well notice this angle right here is 50 degrees because 40 degrees plus 50 degrees is 90 degrees. And these two have to add up to 90. So then the measure of this angle is going to be 63.4 degrees minus that 50 degrees. So 63.4 degrees minus 50 degrees equals 13.4 degrees. So now then, this angle is going to be 90 degrees minus 13.4 degrees, which gives us 76.6 degrees. So then the bearing, this location, is going to be described as south 76.6 degrees east, and that's what we were looking for. Okay, now we're doing question 3 on the review for 7.1, and here's what it's based on. Page 535, it states that the cofunctions of complementary angles are equal. In other words, the sine of 80 degrees, in fact, let's say that I'll call this hypotenuse 1, and this is y, and this value is x. And look at this. The sine of 80 degrees equals y over 1, which is y. The cosine of 10 degrees, the side adjacent, is y, and y over 1. Say, what this shows is, what's stated on page 535, that cofunctions of complementary angles are equal. These angles are complementary. The sum of the two angles is 90 degrees. So now we can replace cosine of 10 degrees with sine of 80 degrees divided by sine of 80 degrees, and that just equals 1, and we're done.